Okay, today we are talking about set theory. Now let's get started by first knowing what is set. Now set is a well-defined collection of objects, data or number. Now this is the first thing you have to know under sets. The second thing you have to know under set is that set is denoted with capital letter. Set is denoted what? With capital letter. Say so if I want to talk about set A, so when they say set A, it means capital letter what? A. And then the element is denoted with, what would that be? Small letter. So when they talk about small letter, it means the element. So if you have A now, this is an element. I guess what I'm saying. So capital letter A is a set and small letter A is an element. Then if I want to say A belongs to capital letter A, let's assume I want to say X. Let's say another element X. Then I want to say X belongs to A. If I want to write X belongs to A, I'm going to write it as X belongs to what? To A. So this sign denotes membership. So know that sign denotes what? Membership. So whenever you see this sign, it denotes membership. So X is a member of what? A. So if I want to say X is not a member of A, I'll write what? X is not a member of what? A. So this one shows that it is not a member of A. Now the next thing you also have to know about sets is that when we say a set is finite, when we talk about finite and infinite set, finite set means the number of elements is countable. So if the number of elements are countable, then we say the set is finite. If the number of elements is uncountable, then we say the set is what? Is infinite. So for example, let's say I have a set A. Let's say I have a set A and I have a set B. Let's say set A means is all positive integers. And let's say B is all positive integer. All positive integers less than 10. Now, if they ask you, is A finite or infinite, and is B finite or infinite? Here we can see that this A is infinite. This A is what? Is infinite. Why? Because we don't know where it's going to stop. I get what I'm saying? We don't know where it's going to stop. I get what I'm saying now. So we will say that set A is what? Is infinite. Now set B, they said all positive integers less than what? 10. Here we can see that our set B is finite because I know where the number is going to stop. So this is what? Is finite. So in other words, finite means when you know the beginning and the end of the number. Infinite means you don't know the end of the number or you don't know the beginning of the number. So those are the other things we need to know under set also. Then let's go to the major things we need to know under set also. One of the things we also need to understand under sets is cardinality of set. So when they say cardinality of set is denoted with n open bracket A. So that means this one means cardinality of what? Of set A. Now if I want to talk about cardinality of set A, let's say I have A equals to, I have a set 1, 2, 3, 7, 9. Now the cardinality of set A here, the cardinality of set, okay, let's have another example. B. Let's say I have A, E, I. Now the cardinality of set A here, the cardinality of set A will be the number of elements you have in A, and that would be what? 1, 2, 3, 7, 9. How many numbers do you have here? 1, 2, 3, 4, 5. That means the cardinality of set A is what? 5. So I'm sure you can know what the cardinality of B will be now. The cardinality of B will be what? 1, 2, 3. So that is what? 3. And that is how you can find your what? The cardinality of a set. So let's proceed now. Let's assume I'm being told to find the cardinality of a set A now, and my A, let's assume my A now is empty. Now, what is the cardinality of this kind of set? You can't say the cardinality is 0. You will say the cardinality is what? Is 1, because it is an empty set. And when we talk about subsets, we will also talk about an empty set is also a subset. So cardinality of this will be what? Will be 1. Then the next thing we have to know is power set. Power set means the set of all possible subsets of a number. So let's say I have let's say I have my A now to be A, E, I. Now, you know that the cardinality of this A is what? 3, right? Now, if we want to get the power set, it will what? 2 raised by what? N, and that will be what? 2 raised by what? 3, which will give me what? 8. Do you understand? So the power set, a formula used to get power set of a set is 2 raised by what? N, where your N is what? Is the cardinality of the set. So that is 8. So you have 8. That means power set of this is 8. And if you want to write it out, you will have 8 possible subsets. So if you want to do it, the first one will be an empty set, then followed by what? A, followed by what? E, followed by what? I. Then the next one will be what? A, E. The next followed by A, I. I get what I'm saying. Then the next one was E, I. E, I. Then what? A, E, I. So I'm sure we can see that now. These are 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is the subset of, this is the power set of this set. Now, the next thing we have to know also is subset and superset. So let's say I have A and B. Let's say I have 1, 2, 5. And I have my B. And I have my B to be 2 and 5. Now, from here, we can see here that since what is in B is in A, I get what I'm saying. Since what I have in B is in A, then I will say what? My B is a what? Is a subset of what? Of A. Do you understand? So we say what? B is a what? Is a subset of A. So this sign denotes subset. Now, since there are some elements in A that are not in B, so we can see that one is here and one is not here. So I will say that what? A is a what? Is a superset of what? Of B. I get what I'm saying? Because there are some elements in A and are not in what? In B. So therefore I will say what? My A is a what? Is a superset of what? Set B. Do we understand that now? So that is on subset and superset. Then the next thing you need to know is the universal set. The universal set is denoted with these two symbols. Then what is the universal set? The universal set is the set that contains all other sets under consideration. So the set that consists of all the other sets in consideration is called the universal set. Then the next thing you need to know is the complement of a set. So this is the universal set. Then the next thing you need to know is the what? Complement of a set. Now I want to talk about complement of a set. If I want to find the complement of a set A, it is noted as what? A complement. You write it like this, or you write it like this, A prime. So when you see these two signs, it means complement. Now, what is the complement of a set? The complement of a set are those elements that are in the universal set that are not in A. So let's say an example. Let's say I have universal set to be what? To be 1, 2, 3, 4, 5. And I have A to be what? 2, 4, 5. Now, my A complement, I said the complement of a set A are the elements in the universal set that are not in what? That are not in A. Now, if you look at your A, you have 2 here, you have 2 here, you have 4 here, you have 4 here, you have 5 here, you have 5 here. So the things that are not here are 1 and what? And 3. So that means your A complement is what? 1 and 3, because 1 is in universal set, but it is not in what? In A. Let's quickly see an example again. Let's say I have this, and I have A, E, I, O, U. Then I have my A to be what? B, C, D, E, F. Now, my A complement will be the things that are here that are not what? That are not here. So, what are the things here? I have A here, and it's not here. I have I have O, and I have what? U. Do you understand complement and universal and complement of a set now? Then the next thing we need to know are the popular ones, which are the union and the intersection of a set. The union of a set is denoted with the word or, and it is denoted with this. Let's say I have a set X. It is denoted as X such that, okay, let's say I have Y union X. We'll denote it as X such that X is in Y or X is in what? X. That is either X is a member of Y or X is a member of what? X. Don't forget, the capital letter is used to denote what? The set X. So the next thing for intersection is denoted with the word and. So whenever you hear the word and, it means intersection. So let's say I have Y intersection X. How will I denote that? I have what? X such that X is a member of what? Y, and X is a member of what? X. Do you get that now? Let's quickly see an example. Let's say I have an example like Y is equals to 1, 2, 3, 4, and 5. And my X is equals to 1, 3, 5. Now, if I want to do my Y union X, that will be what is in X or Y. That is what you have in X or in Y. Now, it means the combination of the two. But one thing you must know is that you must not write one number twice. So, for example, now this, 1 is here, 1 is here. I get something, so I cannot write 1, 1. So what I'll do is I'll write 1, 2 is here, 2, 3, 4, and what? 5. So this is the union of this set. Then for intersection, Y intersection X will be what? What is in Y and also in what? In X. That is what they have in common. Now if you look at it clearly, you see that what they have in common is 1. 1 is here, 1 is here. So that's 1. 3 is here, 3 is here, that's 3. 5 is here, 5 is here, and that's what? 5. That means your Y intersection X is what? 1, 3, and 5. Then the next thing I need to talk about is the set difference. Now, this set difference of a thing is very, very simple. Now, let's say I have a question like Y equals to, let's say I have my Y to be L, M, N, O, P, Q, and R. P, Q, R, and S. And I have my X to be what? Let's say H, comma, I, then O, P, Q, R, S again. O, P, Q, R, and S again. Now, if I want to get my x minus y, let's say I want to get x minus y. Now, how will you get your x minus y? Your x minus y means what is in x that are not in what? In y. I get what I'm saying. What is in x that are not in what? In y. So if you look at it clearly, you see that the only thing that are there is what? H and what? I. That is, h and I are in what? Are in x, but they are not what? They are not in y. Then if you want to do y minus x, you go again. That means what is in y that is not in what? In x. What are in y that are not in x? L, M, N. So that is the set difference. That is, the set difference is what you have in the first letter that are not in the second letter. That is just the definition. So if it is x minus y, that means what is in x and is not in what? In y. If it is y minus x, that means what is in y and are not in x. So that is where we are going to stop for today. I'm sure you've learned something. Please don't forget to subscribe to the channel to receive more lectures in mathematics. Thank you very much, and Colossus, also great.